NEC Section 392.10 requires a minimum of 1/2 inch clearance between knob and tube conductors and other conductors, including those in electrical metallic tubing or EMT. Covering knob and tube conductors with loom does not exempt them from the minimum clearance requirement. The loom is not considered a suitable insulating material in this context. There is no provision in the National Electrical Code, or NEC, that allows for zero clearance between knob and tube and EMT, even if the conductors are insulated. Fiberglass sleeving can be used to provide additional insulation between knob and tube conductors and EMT. However, this must be done in addition to the minimum clearance requirement. It is recommended to maintain a minimum of 1 inch clearance between knob and tube and EMT to provide ample space for potential movement and reduce the risk of contact or arcing. The code section that addresses this issue is NEC Section 392.10a. This section states that conductors of different systems, including those of circuits and branch circuits and those of different circuits, shall not be grouped together unless separated by an approved barrier or unless all conductors within the group are insulated for the highest voltage present. Let's delve deeper into the specifics of these regulations and recommendations. Firstly, understanding the implications of NEC Section 392.10 is crucial. This code mandates a minimum separation of 1/2 inch between knob and tube wiring and any other conductors, including those encased within EMT Conduit. This requirement isn't arbitrary, it's rooted in safety considerations aimed at preventing potential electrical hazards. The primary concern revolves around the risk of arcing or short circuits, which can occur if the insulation on either the knob and tube wiring or the conductors within the EMT were to degrade or become compromised over time. Maintaining this spatial separation minimizes the likelihood of such events. Secondly, it's important to address the common misconception regarding the use of loom to cover knob and tube wiring. While covering knob and tube conductors with loom might seem like a practical solution to improve insulation and reduce the risk of contact, it's crucial to understand that it doesn't exempt the wiring from the minimum clearance requirement stipulated by the NEC. The NEC doesn't recognize loom as a sufficient insulating material in this particular context. Therefore, even if the knob and tube wiring is diligently covered with loom, the 1/2 inch clearance from other conductors, including those in EMT, must still be maintained to comply with code regulations. Thirdly, the NEC doesn't provide any provision that would allow for zero clearance between knob and tube wiring and EMT, even in scenarios where the conductors are thoroughly insulated. This restriction underscores the paramount importance of maintaining physical separation between different wiring systems to mitigate the risk of electrical faults. Regardless of the type or quality of insulation used, the potential for insulation breakdown or physical damage necessitates adherence to the minimum clearance requirements outlined in the NEC. Fourthly, while the NEC doesn't permit zero clearance, there are alternative measures that can be taken to enhance insulation and further minimize the risk of electrical hazards. One such measure involves the use of fiberglass sleeving. Fiberglass sleeving can be employed to provide an additional layer of insulation between knob and tube conductors and EMT. However, it's crucial to recognize that this supplementary insulation doesn't negate the need to comply with the minimum clearance requirement. The use of fiberglass sleeving should be regarded as an enhancement to, rather than a replacement for, the mandated spatial separation. Fifthly, beyond the minimum clearance requirements stipulated by the NEC, it's often prudent to adopt a more conservative approach and maintain a greater separation distance whenever feasible. A recommended clearance of 1 inch between knob and tube wiring and EMT is generally considered a best practice. This increased separation provides a greater margin of safety, accommodating potential movement or shifting of the wiring or conduit over time. Additionally, it further reduces the likelihood of accidental contact or arcing, thereby enhancing the overall safety and reliability of the electrical system. In summary, when dealing with knob and tube wiring in proximity to EMT conduit, adherence to the NEC regulations and recommended practices is paramount. Maintaining the minimum clearance of 1/2 inch, understanding the limitations of loom as an insulating material, recognizing the absence of provisions for zero clearance, considering the use of fiberglass sleeving for enhanced insulation, and aiming for a recommended clearance of 1 inch are all essential steps in ensuring a safe and code-compliant electrical installation. Now let's expand on the different aspects discussed so far, beginning with a more detailed examination of NEC Section 392.10a. This section isn't just a mere recommendation, it's a legally enforceable requirement that carries significant implications for electrical installations. Understanding the rationale behind this code provision is crucial for ensuring compliance and preventing potential hazards. A primary objective of NEC Section 392.10 is to minimize the risk of electrical faults arising from the interaction between different wiring systems. Knob and tube wiring, an older method of electrical wiring, typically lacks the same level of insulation and protection as modern wiring systems. Consequently, it's more susceptible to damage, degradation, and insulation breakdown over time. When knob and tube wiring is in close proximity to other conductors, such as those within EMT Conduit, the risk of arcing or short circuits increases significantly. These electrical faults can lead to a range of adverse consequences, including fires, equipment damage, and even personal injury. By mandating a minimum clearance of 1/2 inch between knob and tube wiring and other conductors, NEC Section 392.10 aims to create a buffer zone that reduces the likelihood of electrical faults occurring. This spatial separation provides a degree of protection against accidental contact, insulation breakdown, and the propagation of electrical arcs. However, it's important to recognize that the 1/2 inch clearance is just a minimum requirement. In certain situations, a greater separation distance may be necessary to adequately mitigate the risk of electrical hazards. Factors such as the age and condition of the knob and tube wiring, the voltage level of the circuits, and the environmental conditions in the vicinity can all influence the appropriate clearance distance. Next, let's address the misconceptions surrounding the use of loom as an insulating material for knob and tube wiring. Loom, a flexible, woven or braided sleeving, is often employed to provide additional protection to electrical conductors. While loom can offer some degree of physical protection against abrasion and mechanical damage, it's not recognized by the NEC as a substitute for proper insulation. The NEC mandates that all electrical conductors be adequately insulated to prevent electrical faults and ensure safe operation. The type and quality of insulation required depends on various factors, including the voltage level, the operating environment, and the applicable code requirements. In the case of knob and tube wiring, the insulation typically consists of a rubber or thermoplastic compound applied directly to the conductor. Over time, this insulation can degrade due to heat, moisture, and other environmental factors. While loom can provide some additional protection, it doesn't address the underlying issue of degraded insulation. Furthermore, loom is often porous and can absorb moisture, which can further compromise the insulation of the conductors. Therefore, even if knob and tube wiring is meticulously covered with loom, the 1/2 inch clearance requirement must still be observed to comply with NEC regulations. The loom is not considered a sufficient substitute for proper insulation, and it doesn't negate the need for spatial separation to prevent electrical faults. Now let's clarify the NEC stance on zero clearance between knob and tube wiring and EMT conduit. The NEC doesn't permit zero clearance between these two wiring systems regardless of the type or quality of insulation used. This prohibition underscores the fundamental principle of maintaining physical separation between different electrical circuits to minimize the risk of electrical hazards. The rationale behind this restriction is multifaceted. Firstly, even with high-quality insulation, there's always a risk of insulation breakdown due to aging, environmental factors, or physical damage. If knob and tube wiring and EMT conduit are in direct contact, any insulation failure could result in an immediate electrical fault, such as a short circuit or ground fault. Secondly, direct contact between dissimilar materials can lead to galvanic corrosion, which can accelerate the degradation of the wiring and conduit. Galvanic corrosion occurs when two different metals are in electrical contact in the presence of an electrolyte, such as moisture. This process can weaken the materials and increase the risk of structural failure. Thirdly, even if the wiring and conduit are initially installed with zero clearance, there's a possibility of movement or shifting over time due to building settlement, thermal expansion, or other factors. This movement could cause abrasion or chafing of the insulation, leading to eventual failure. For all of these reasons, the NEC strictly prohibits zero clearance between knob and tube wiring and EMT conduit, regardless of the insulation quality. Maintaining the specified minimum clearance is essential for preventing electrical faults and ensuring the long-term safety and reliability of the electrical system. Let's explore the potential benefits of using fiberglass sleeving to enhance insulation between knob and tube wiring and EMT conduit. Fiberglass sleeving is a type of flexible insulating tubing made from woven fiberglass yarns. It's commonly used in electrical applications to provide additional protection to conductors and components. While fiberglass sleeving isn't a substitute for proper insulation, it can offer several advantages when used in conjunction with existing insulation. Firstly, fiberglass sleeving provides an additional layer of physical protection against abrasion, cuts, and other forms of mechanical damage. This can be particularly beneficial in areas where the wiring is exposed or subject to potential contact with sharp objects. Secondly, fiberglass sleeving is highly resistant to heat, moisture, and chemicals. This can help to extend the lifespan of the underlying insulation and prevent premature degradation. Thirdly, fiberglass sleeving has excellent dielectric properties, meaning that it can withstand high voltages without breaking down. This can provide an extra margin of safety in situations where the wiring is exposed to high voltage surges or transients. However, it's crucial to understand that fiberglass sleeving doesn't negate the need for proper clearance between knob and tube wiring and EMT conduit. The NEC requires that the specified minimum clearance be maintained, regardless of whether or not fiberglass sleeving is used. The fiberglass sleeving is simply an additional layer of protection that enhances the overall safety and reliability of the electrical system. Now let's discuss the importance of maintaining a recommended clearance of 1 inch between knob and tube wiring and EMT conduit. While the NEC mandates a minimum clearance of 1/2 inch, it's often prudent to adopt a more conservative approach and maintain a greater separation distance whenever feasible. A recommended clearance of 1 inch provides a greater margin of safety and reduces the likelihood of electrical faults. There are several reasons why a larger clearance is beneficial. Firstly, it allows for greater tolerance in cases where the wiring or conduit may shift or move over time. Building settlement, thermal expansion, and other factors can cause slight movements in the structure, which can affect the position of the wiring and conduit. A larger clearance provides more room for these movements without compromising the safety of the installation. Secondly, a larger clearance reduces the risk of accidental contact or arcing. If the insulation on the wiring or conduit were to become damaged or compromised, the increased separation distance would make it less likely that an electrical fault would occur. Thirdly, a larger clearance provides better ventilation around the wiring, which can help to prevent overheating. Overheating can accelerate the degradation of the insulation and increase the risk of electrical faults. For all of these reasons, it's generally recommended to maintain a clearance of 1 inch between knob and tube wiring and EMT conduit, even though the NEC only requires a minimum of 1/2 inch. This extra margin of safety can significantly reduce the risk of electrical hazards and ensure the long-term reliability of the electrical system. Let's summarize the key points regarding knob and tube wiring clearance from EMT conduit. Firstly, NEC Section 392.10 mandates a minimum clearance of 1/2 inch between knob and tube wiring and other conductors, including those in the EMT conduit. Secondly, covering knob and tube conductors with loom does not exempt them from the minimum clearance requirement. Loom is not considered a suitable substitute for proper insulation. Thirdly, the NEC does not permit zero clearance between knob and tube wiring and EMT conduit, regardless of the type or quality of insulation used. Fourthly, fiberglass sleeving can be used to provide additional insulation between knob and tube conductors and EMT conduit. However, this does not negate the need to comply with the minimum clearance requirement. Fifthly, It is recommended to maintain a clearance of 1 inch between knob and tube wiring and EMT conduit to provide a greater margin of safety and reduce the risk of electrical hazards. By adhering to these guidelines, you can ensure a safe and code-compliant electrical installation that minimizes the risk of electrical faults and protects against potential hazards.